Hey, ladies and gentlemen, welcome to Forces 2, Lesson 5, and we're going to be doing how are kinetic and potential energy different. And so we're going to be looking at kinetic energy as well as potential energy as we are going and taking a look at different contexts and seeing how they're different and how they transfer from one to another. In this lesson, in Lesson 1, we're going to be learning about the difference between the two. Okay, so we're going to be looking at that and as well as many different examples that we have. Okay, so with that, let's take a look. And basically, whether something's standing still or moving, all objects have energy. And so even, a basketball at the top, right as it's going down, or even, the water in here that we have in the Hoover Dam down over in this river, in this example here, you have energy. And so right now, even though it's a lake, even though it's standing still, you can only imagine if this dam were to break and it were to go all the way down the river, it would have tons of energy. And so right now, it's not showing it, but it has the potential to have loads of energy behind it. Okay, and so that's what we're going to be looking at for this. And so kinetic energy, simply put, kinetic, if you were doing kinesthetics, basically in, let's say, gym class, it's basically movement. So kinetic energy is just basically energy in motion. So for example, I'm looking at this basketball here. It's bouncing up and down. And so we also have cars that are moving. And also as I go down the hill on skis, I'm also showing movement. Okay, so energy in motion is kinetic energy. There are many other examples too. And so I'm going to be looking at this a little bit later, why we have this change here. We're going to be looking at that. But right now we're just looking at motion. Kinetic energy is energy in motion. And so maybe the more energy we have, the more motion we'll have, like the more speed. Okay, now we have potential energy. And potential energy is also known as like gravitational energy. So like if I were to write this down here, it'd be more like energy due to its position. Okay, gravitational energy. Okay, so it's usually used in both terms, but it's stored energy because of its state or position. And often you'll usually hear it of just, like a rubber band being pulled back, and also just like a bow and arrow. As it's being pulled back, the farther it pulls back, the more energy is being stored behind it. Because the moment you let it go, it's going to go. And same thing with springs as well. The farther you let the spring go and then you let it fly, it's going to expand in size and it's going to let loose of that whatever its load is at the moment. So like, a jack-in-the-box or suspensions on a car. Those are examples of potential energy too. Also, one thing you might not have thought about is height. The idea of gravitational energy, the height it is from where it's at. So as it's at the top of a hill or at the top of its, on a yo-yo at the bottom or anything else based on height, if it is let go, it will then transfer from its potential at its height to kinetic as it falls. And kinetic energy is energy in motion. Whereas potential energy is energy due to its state or position, where it's at, stored energy. I'm going to write here, due to state, which might often mean if it's in stress, or like as far as a rubber band, it's being stretched, or as a spring that's being crushed or pushed down and all that tension there, or position, meaning where it's at that it would have. And so that is lesson 5 that we have, where we have kinetic versus potential. Okay. And so next lesson that we're going to do is how do we change from kinetic to potential and vice versa? And how does that occur in everyday life?